Alright, so I'm going to review rates and accumulation for AP calculus. So this is a very important skill because there tends to be a lot of FRQs on this topic. So let's kind of imagine that we have some function like uh, this f of t. So rates and accumulation functions will generally be with respect to time because it is a rate. So let's say you have some function and it just says this is how much snow is happening over the course of an hour. Or not over the course of an hour, just hey, this is a function that represents how much snow we have. And so it's just like 1 over x. Some function 1 over square root x. I don't know. So we have this function and this is the rate. This this function represents how much snow, actually this would be 1 over t, but this represents some rate at which snow is falling. If this is the rate, then what we need to do is this would be in like inches per second. And so what we need to do is we need to integrate with respect to time to get rid of this seconds thing. So then we would just go dt, and then we would find, technically I think this would be lowercase f, if we wanted to use the fancy like antiderivative notation. But if this would be what you would do to solve for the actual amount of snow. If you were given a rate, then you integrate to find the amount. So now we have an actual problem. We have this snow problem. We have this S of t represents this snow in inches per hour. So we have our rate here, which, and we need to find how many total inches. So we know that you integrate a rate to get the total. So we know to integrate this S of t function to get the total amount of snow. So that's just 18 times t plus 3 dt. And we want it to be between 0 and 4 hours. So our bounds of integration are 0 to 4. And we know with the basic integration, this is 18 natural log of t plus 3 from all from 0 to 4. And then let's substitute our values. 18 ln 4 plus 3 is 7 minus 18 ln of 3. And you can leave this as your answer. I literally just looked up Calc BC rates and accumulation. Or I just, and there's like a whole page, and there's basically one every year. And I looked up just the most recent one. This is one from 2022. It's the first question. There's one basically every year. So it's very, very important that you understand. It's nothing that we really haven't covered before. It's just very important that you see the relationship between derivatives and integrals in this. So let's look at the question. From 5 a.m. to 10 a.m., the rate is given by this function a of t. All right, we have this function a of t. Also, because this is a question 1, we are allowed to use a calculator, so grab your calculators if you care. And then I might go do one that is non-calculator. But we have this a of t where t is the number of hours after 5 a.m. So 5 a.m. is t equals 0, measured in vehicles per hour. So we have, this is a rate, this is a rate, this is a rate. So no vehicles waiting in line. Write, but do not valuate. So just write an integral. So for a, we're just going to have something with an integral. That gives the total number of vehicles that will arrive at the whole plaza from 6 a.m. So that it literally tells us t equals 1 to 10 a.m. t equals 5. So we know that the bounds of integration are going to be 1 and 5. And so we want to find the total number of vehicles. Well, we have the vehicles per hour. So we just write the integral of a of t with respect to t, which is just 450 sine of 450 times the square root of the sine of 0.62t, 0.62 t dt. And I don't have the scoring guidelines, so I don't know how many points this would be. Like, they're not released yet. But I would assume this is probably just like 1 point. But it's a free point. Alright, let's look at the next question. Find the average value. I did a video about that. I know how to do average value from t equals 1 to t equals 5. Cool. So we have this integral expression from part A. So what if we know we can put this integral expression into our calculator. This is a calculator question after all. So 1 to 5, and then I'm just gonna, instead of rewriting the whole thing, I'm gonna write a of t dt, and average value is just multiplied by 1 over 5 minus 1, because this will tell you the total value, and then we divide by the length. And so let me go type this into my calculator. Alright, I am getting a number that is 375. And then I'm going to write about 4 or 5 decimal points just to ensure that I don't butcher these numbers. 6, 9, and 7. And what is this? This is for part B. Find the average value. So this would be a amount of cars per hour. Right. Find the average value of vehicles per hour. Alright, C is the rate at which vehicles arrive at 6 a.m. increasing or decreasing? Okay, so let's see. The rate at which vehicles arrive at 6 a.m. t equals 1 increasing or decreasing. So we need to look at the function and we need to take the derivative of it. And we can just do this at t equals 1. And again, this is a calculator problem, so just type this into your calculator. And so we, if we write out a prime of 1, and so that's 148.94729. So this is a prime of 1. And because a prime of 1 is positive, a prime of 1 is greater than 0, the rate is increasing. So a of t is increasing. at t equals 1. Because if the derivative is positive, the function is increasing. A line forms whenever a of t is greater than 400. Alright, and a number of vehicles, a line is given by this. So we have another integral here. So this is definitely where most of the points came from on this question. I can just see that there's a lot of steps to this. So let's break apart this question. So we want to see the greatest number of vehicles. So if this is for the number of vehicles in a line, we need to take our function n of t and take the derivative and set it equal to 0 to find the maximum. And so if we do that, this is just taking the derivative of an integral, which is fundamental theorem of calculus. So that would just be a of t minus 400 is equal to 0, and a of t is equal to 400. And so this is just your a of t function over here. And so you would just solve for it algebraically. So if you wanted to graph this and try and work this out, there would be a function, you would have your a of t function, and it looks something like that. And then you have just y equals 400, right? And so there's 2 points. And so at this first point, then you need to see basically which one it is. And so we have this first point, t is equal to 1.46937. Then the other one where it equals 400 is t is equal to 3.59771. So we need to basically see at these points, at the 400 point, and then figure out basically the greatest number of vehicles. So it's either going to be at these critical points, at, or at the endpoints. So now we've solved for the critical points. So this is kind of like our endpoint, this first t here, because this is when it is first equal to 400. Yeah. So this is like our initial point, and our other one is at t equals 4. So 4. And then now I need to see the number of vehicles. And so this is just n of t. Substituting these into the calculator, you get 0, you get 71, and 62. So at 71 is the greatest number of vehicles on the central. So just really pay attention to these questions. These rates and accumulation, just figure out exactly what it's asking. And for these calculator questions, use your calculator.